Myself, Bijali, Assistant Professor of Haldia Institute of Technology. Today I am giving a lecture on Thevenin Theorem. I have already delivered a previous lecture on superposition theorem. Then the next statement of Thevenin Theorem. This is the statement. Any linear, active, bilateral DC network having a number of voltage or current sources with resistances can be replaced by a simple equivalent circuit having single voltage source VTH in series with single resistance RTH, where VTH is the open circuit voltage, that is also known as the Thevenin's equivalent voltage. RTH is the Thevenin equivalent resistance that is viewed back into the network from the open circuited terminals. This is the statement of Thevenin theorem. Then the steps to determine VTH and RTH. That means how we can obtain a Thevenin equivalent circuit. So these are the steps. Then the first step, identify and temporarily remove the load resistance through which current is to be measured. That means first, by seeing a network or a circuit, first identify the load resistance and then remove that load resistance from the network. Suppose the terminals are labeled as PQ. Now PQ terminals open circuited. Step 2. Find the voltage across open circuit terminal, and this voltage that is known as the open circuit voltage, that is VOC. This open circuit is VOC and it is also known as the Thevenin's equivalent voltage, that is VTH. Then the step 3, after calculating VTH or VOC, calculate RTH. Before calculating RTH, set all voltage sources short circuited and current sources open circuited. And why voltage sources short circuited and current sources open circuited, I have already discussed that point in my previous lesson or previous lecture. Then step 4, calculate resistance viewed back into the network from the open circuit terminals, and this resistance is known the Thevenin's equivalent resistance, that is RTH. Okay. So after calculating RTH, replace the entire network by the Thevenin's equivalent voltage, that means VTH and RTH. That means Thevenin equivalent circuit having a one voltage source and in series with a resistance, that is RTH. After redrawing this Thevenin equivalent circuit, reconnect the load resistance RL to this circuit. After reconnecting load resistance to the circuit, calculate, this is the last step, calculate the current through the load resistance RL, that is suppose IL. After reconnecting load resistance, calculate the current through load resistance RL. So these are the steps how to calculate VTH and RTH. This is the Thevenin's equivalent circuit. Suppose this is a linear active bilateral network and this RL is connected here. Then by applying the step 1 to step 7, we can obtain this type of circuit, that is this circuit having one VTH and one RTH. Okay, this is called the Thevenin's equivalent network or Thevenin's equivalent circuit. Now explanation. How we can achieve Thevenin equivalent circuit. Suppose this is a one circuit having a voltage source and some resistances. It is E smaller, it is R1, R2, it is R3, and this resistance is RL. Suppose in any circuit not defined RL, then how we can understand which resistance is the RL? Because this is the first step. First identify and temporarily remove RL from the circuit. Actually, how we can understand? The current through which the current is to be measured, that is the RL. Through which the current is to be measured, that is the RL, if it is not mentioned in any network or circuit. As here mentioned here RL, that one, so it is very simple. This is R1 RL. So first step is what? First step is to remove this RL from the circuit or this network. Then again, if we redraw this circuit, then we get this type of circuit. Suppose the terminal name is P and Q. It is R, it is E, it is R1, it is R2, it is R3. Now what I have to do? Now calculate VOC, that is VOC. Now calculate the voltage across the open circuited terminal, and that is known as the VOC as well as Thevenin equivalent voltage, that is VTH. So what will be the VOC? So VOC will be equals to what? VOC will be equals to, as there will be no current flowing through this R2, this resistor. So whatever the voltage drop across this R3, that will be VOC. So VOC will be equals to what? That is the voltage drop across R3. So voltage drop across R3 will be equals to what? Here voltage divider rule is applicable. That is the total voltage, that is E multiplied by this R3 divided by the total resistor. Total resistor will be R, R1 plus R3. This is VOC, and this VOC is also known as VTH, that is Thevenin equivalent voltage. Then next calculate RTH. So before calculating RTH, I have already discussed, remove all the voltage and the current sources from the network by their internal resistances. As the given network contains only one voltage source, so how we can remove? By short circuiting. After removing all the voltage and the current sources, viewed back into the network from the open circuit terminal. Then calculate RTH. So when you calculate RTH, remember, if you not consider a current, we can't understand which resistor are connected in parallel and which resistor connected in series. So always calculate RTH by considering a current. Suppose a current flowing through this R2, and here this is divided in this path and this path. So from this current direction we can understand that this small r and R1, that is in series, and this R and R1, this series combination parallel with R3, and this parallel combination series with R2. Then what will be the equivalent resistance or Thevenin equivalent resistance, that is RTH. So RTH will be equals to R plus R1 parallel R3, and this parallel combination series with R2. This is our equivalent or our Thevenin equivalent resistance. Then after calculating Thevenin equivalent resistance, redraw the circuit, redraw the Thevenin equivalent circuit. So if we redraw the Thevenin equivalent circuit, then we get this is contains VTH and RTH and reconnect RL. After reconnecting RL, this is called the Thevenin equivalent circuit. After reconnecting RL, calculate the current through this RL. If it is IL, if it is denoted by IL, then IL will be equals to what? IL will be equals to VTH by RTH plus RL. This is IL. By this way, we can calculate the current through the load resistance by using Thevenin theorem. Now discuss one simple example. This is one simple example. Find Vx by first finding Vth and Rth to the left of AB. As in this given figure, that is Vx. So Vx is to be measured. So which one is the RL? So this resistance is RL. So first step is what? First step is remove this RL from the network. So remove this RL from this network. This is the circuit. Now AB is open circuited, and then next step is calculate VOC. So VOC, that will be equals to VAB. So it is VOC also. It is VOC. This VOC will be equals to VAB. That will be equals to what? As this current through this 4 ohm resistor is 0, there is no question of current flowing through this R4 because R ohm, because it is open circuited. So the whatever the voltage drop appear across this 6 ohm resistor, that will be equals to VOC. That will be equals to VOC. So VOC will be equals to VAB. That will be equals to, here voltage divider rule is applicable. So the total voltage 30 multiplied by 6 divided by the total resistor, 12 plus 6, 12 plus 6. That will be equals to 10 volt. Okay. Then next, calculate RTH. So before calculating RTH, I have already told, remove all the voltage and the current sources. As this network contain only one voltage source, so only remove this voltage source by short circuiting. Now we get this type of circuit. Now viewed back into the network from the open circuited terminal. If we consider current flowing through this R ohm resistor and here divided in this path and this path, so we can understand that this 12 and 6 is in the parallel, and this parallel combination series with 4 ohm resistor. So RTH will be equals to 12 parallel 6 plus 4, and that will be equals to 8 ohm resistor. This is a very simple example. By applying the steps, we can calculate the VTH and RTH. After calculating VTH and RTH, we draw the Thevenin equivalent circuit. This is the Thevenin equivalent circuit that contains only VTH and RTH and RL. As in this given problem, calculate the Vx through this load resistor. So Vx will be equals to what? Here also voltage divider rule is applicable. Total voltage, that is also given, that is 10 multiplied by 2 divided by 2 plus 8. That will be equals to 2 volt. Then the current through the 2 ohm resistor will be equals to what? Current through this 2 ohm resistor that if it is IL, then IL will be equals to what? If it is IL, then IL will be equals to, we can also calculate IL like Vs. IL will be equals to what? That will be 10 divided by 8 plus 2. That will be equals to 1 ampere. This is the current through load resistor, and this is the voltage across this load resistor. I think all of you understand how we can calculate this VTH and RTH. Next, the another example. Determine the current through 5 ohm resistor in the circuit shown in below. Here directly not mention the RL, but given current through 5 ohm resistor. So from this example we can understand that this 5 ohm resistor, that is the RL for this given circuit. Okay, so this 5 ohm is the RL. It is identified. Now open remove this RL from the network. So if we remove this 5 ohm resistor from this network, then we get this type of circuit. After removing 5 ohm resistor, calculate VOC. So VOC will be equals to what here? VOC will be equals to what? This VOC, as this VOC is directly connected to this 5 volt, that means VOC will be equals to VOC, the open circuit voltage will be equals to 5 volt. It is very simple. And this VOC will be equals to also VTH. This VOC also equals to VTH. Now calculate RTH. After removing all the voltage and the current sources, we get this type of circuit. It is open circuited, and then what will be RTH? The resistance given, that is 1 ohm and it is 2 ohm. It is 1 ohm and it is 2 ohm. Then what will be the RTH? As this, if we consider by a current, then all current flowing through this short circuited path, because current always follow the low resistance path. So what will be the R equivalent? So R equivalent or R Thevenin equivalent resistance, that will be equals to 0, because all the current, as there is a short circuit path, so all the current flowing through this short circuit path, not follow this path. So the RTH will be equals to 0. After calculating RTH, draw the Thevenin equivalent circuit, and this is the Thevenin equivalent circuit. This RL is 5. RL is 5 ohm. So what will be IL or I5? That means current through the 5 ohm resistor. If I indicate that is I5, then I5 will be equals to what? It is VTH, it is RTH, it is VTH, and it is RL, VTH by RTH plus RL. As here VTH is 5 by 0 plus 5, so it will be 5 upon 5, and that will be equals to 1 ampere. This is the current through 5 ohm resistor. I think all of you understand Thevenin theorem and the statement, and how to calculate VTH, that is Thevenin equivalent voltage, and RTH, Thevenin equivalent resistance, and the current through the load resistor from my lecture. Then the next lecture I will deliver Norton's theorem. So thank you all of you.